Hello everyone, my name is Berkasat, and today I will be talking about my design for the final project, Multimodal Giant Chess. I want to start by saying that we all know many people enjoy playing board games. And as fun as they may be, during quarantine especially, we all had to rely on playing them online with a bunch of mouse clicks and a bunch of sort of moving the touchpad and all of that, which lost some of the fun for us, right? Because you don't get to interact with the game as much. So then I was thinking about the virtual reality applications where you do get to interact with the game a lot. And there is a lot going on in this field, and it's going pretty great, except it's not very accessible for you and all of your friends to get your each VR set and sit around the table and play like that. So I was thinking about how to make this interaction a bit more accessible to people, right? And if you think about board games, there's always the same logic essentially. You have some grid, you can distribute the grid in some way, and then after you split each section, you can assign each section to be some meaningful thing in the game, and then you can input and output using the user moves, and you can have some like cards inputted as well. So you can sort of create this environment where you do get to control the game on a grid perspective, right? But instead of creating this entire scheme, I will be focusing more on a demo with the chess game. So what my demo in the real life scenario will be is that you can sort of, I'm calling it giant chess because you will be sort of like the same size as the chess pieces in this game, right? You will be sort of the human walking around the grid by walking in place in real life. The camera will see you walking in place and it will move you along the grid. And then you will be able to sort of steer your direction with moving with the speech. And then you will be able to get to the grid with a piece, and you will be able to sort of pick up that chess piece, and then you will be able to move it around in accordance with the rules of chess. And this will sort of be the real life scenario of someone interacting with the system I'm trying to create here, right? And diving a bit more into the modal interaction with the game, you first want to select the chess piece to move. And this happens when you walk along the grid. And as you are walking in place, the classifier will see your motion through the camera and it will classify it as walking. And once the classification is done, and if it's walking, then we will start counting the steps that you're actually taking using the phone IMU, the phone data, the step data from your phone. And then eventually we will be moving you along the grid with each step. And to change the directions, you can have speech commands like turn right, turn left, turn back. And if you first say this command and then take another step, you will see that your direction was steered from what it used to be. Now, the next thing you want to do is to move the chess piece. And with this one, once you are on a grid with some chess piece, you do some pushing motion. And this is classified by the exact same model that classifies the walking. And once you do that, you walk with the exact same logic as before, and which will basically move the object and place the object in a new grid as long as the move itself is valid from a perspective of like the rules of the game. So then eventually you complete your turn by saying none, and it automatically will switch to your opponent's turn and they will continue doing the same thing. So for the implementation part, we first start with a visual input coming from a laptop camera, and then we do 3D pose detection. We get some skeletal pose of the body using the OpenPose and OpenCV libraries. And then we do activity classification with a pre-trained model that already handles the walking in place and running in place, and also the pushing motion. And then we have the phone IMU data, and we will be using Touch OSC, as our team mentioned on Tuesday, to transfer the step data onto our computer. And eventually we will use a speech input, and we will be using the Web Speech API to process the speech. And after we have all of these inputs, then we can take all of them in, create the motion, and display the motion on the Giant Chess GUI, which will be a grid with the chess pieces and you also visible on the grid as shown before, right? So this will be the implementation of my final project, and that will be the end product. So thank you so much for listening.